video, we're going to look at the probability of independent events. Now, independent events are where there are more than one event and neither event affects the outcome of another. For example, we could have you throwing a coin, okay, and you get a head the first time. You throw it again, that doesn't impact on the next outcome. You still got an equal chance of getting a heads or a tail. So therefore, those are independent events. And when we have independent events, we know the probability of the two things happening is equal to the probability of A times the probability of B. So the probability of getting a head the first time is a half. Probability of getting a head the second time is also a half. So probability of getting a head followed by head is a half times a half. Let's say you were throwing a head and rolling a dice. So the probability of getting, and you wanted to find the probability of getting a head followed by a 6. So the probability of getting a head the first time is a half. Probability of getting a 6 the second time is 1/6. So the probability of getting a head followed by a 6 is 1/2 times 1/6. And this is the probability of getting independent events. So the intersection is having the head and the 6 in those two throws of the dice and the coin. Now, if you've got 3 independent events, then the probability still times together just like that. Right, let's just have a look at an example. So here we go. We've got each of these spinners are spun once. Okay, find the probability of spinning a green with this spinner and a blue with spinner 2. So if we do this, so probability of green with spinner 1, and we want a blue with spinner 2. So probability of green with spinner 1 is a quarter, because the area is a quarter of the circle that you can land in. And then the probability of blue is 1/6, because there are 6 equal shapes, and we've got only one of them blue. So therefore, the probability of green followed by blue is 1/24. Now, if we want to do part B, probability of red with both spinners. So we've got a half, because that's 2 quarters, which is a half. And then we've got 2/6, which is a third. And we get a half times a third, which is 1/6. Right, on to another question. We're going to look at 3 questions, and then you can have a go at some yourselves. So, a coin is tossed 3 times. Determine probability of getting the following sequence of results. So, probability of head, followed by head, followed by head, followed by head. Well, each of these is independent. Each of them is a half, because you can get heads or tails. Coins don't tend to land on their edges. And if they do, it's so minusculely rare, we can't really allow for it. So we get 1/8. Part B, we want a tail, followed by a head, followed by a tail. So it's in that order. So the probability of getting a tail the first time, times by the probability of getting a head the second time, times by the probability of getting a tail the third time, is also equal to 1/8. Now, if it was just 2 tails and 1 head in any order, then we'd need to also consider tail, tail, head, and head, tail, tail, which is also 1/8. So therefore, you'd get 3/8 in total for that. Right, last one here. All these questions were assuming independence. Okay, the outcome. So machine A has an 8% chance of malfunctioning. Machine B has 12% malfunctioning. We're assuming that machine A cannot affect machine B. Determine the probability on any given day both machines will malfunction. So P, that A malfunctions followed by B malfunctions is going to be 8% or 0.08 is a better way of doing it, times by 0.12. And that comes out to be equal to 0.0096 when we use our calculator. So that's part A. Part B, that they work effectively. So you've got P A does not malfunction and B does not malfunction. So therefore, if A malfunctions 8% of the time, it will work perfectly 92% of the time. So it's 0.92. And if this malfunctions 12% of the time, it will work perfectly 88% of the time. And if we times those together, we get 0.809. 6. So if you know that you've got independent properties, we can see that the questions are really quite straightforward.